Hello everyone, hope all of you guys are doing well, and this is your experiment 12B, which is voltaic cells. Okay, let's see how to answer these questions. Okay, so you are given this oxidation reduction reaction and it is balanced, and we want to find out the oxidation number of carbon in sodium oxalate. Okay, so how do we find the oxidation number? We learned about this in your General Chemistry 1 course, right? Let's see. So this is a neutral compound, Na2C2O4. So in a neutral compound, when you add up the oxidation numbers for each one, it should equal to 0. For example, here we have 2 sodium ions plus 2 carbons, plus 4 oxygens. So when you add up their oxidation number, since this is a neutral compound, it should equal to 0, right? And then there are some oxidation numbers that is quite easy for us to find out from the periodic table. For example, sodium is in group 1. So the group 1 elements normally form +1 oxidation state. So each sodium ion is +1. So 2 times +1 which is going to be 2. And then carbon is what we want to find out. Carbon in group 4, carbon can be +4, it could be +3, so we don't know. We're going to leave carbon as a mystery, so we'll keep it as carbon, 2 carbon, like that. And then the oxygen is in group 6. So group 6 normally makes -2 oxidation number. So 4 times -2, all of these equals 0. So 2 times +1 is +2, plus 2 carbons. 4 times -2 is -8, equals 0. Okay, so 2 plus 2 and -8 is -6. So 2 carbon, -6 equals 0. And then carbon then would be, how do you find carbon? So we can find out 2 carbons are going to be, you take the -6 into the other side, +6. So then the carbon oxidation number going to be 6/2 plus 3. So carbon oxidation number is 3. Okay, so you can answer over here, oxidation number for carbon is 3. And similarly, you can find out question number, we were doing question number 1, right? I entered in question number 2, but you can go back and enter it in the appropriate place, question number 1. Okay, and then for the second one also you follow the same way. Now this one is asking what is oxidation number of carbon in carbon dioxide. Okay, so carbon, again, this is a neutral compound. When you add up the oxidation number, so it's not a charged compound, it's not an ion. So carbon plus 2 oxygens equals 0. Oxidation number is -2. So -2 times 2 is -4 equals 0. So then the carbon would be +4 oxidation state. Okay. And then based on answers to question 1 and 2, were carbon atom oxidized or reduced in this reaction? Remember, carbon going from +3 to +4. What happened to the oxidation number? Oxidation number increase. If the oxidation number increase, what do you call that? That is an oxidation. If the number increase, that is oxidation, right? So that means carbon atoms were oxidized. Next one, similarly, you want to find out the oxidation number of manganese in potassium permanganate. So potassium permanganate, we can either go by knowing the oxidation numbers of potassium and oxygen and then find out manganese, or we can separate them into its ions, potassium permanganate. So the 2 ions, that is form potassium permanganate is, if you break them into ions, KMnO4, there would be K plus MnO4. So permanganate is a polyatomic ion, MnO4. Now polyatomic ion, you have now a charge for MnO4 minus. So what do? We can use the same way that we used before. Now it has a charge. So when you add the oxidation number for manganese plus the oxidation number for the 4 oxygens should equal the charge of the ion, which is -1. And we know oxygen is -2. -2 times 4, -8. Manganese -8 equals -1. So then the manganese would be -1 plus 8 plus 7. So the oxidation number for manganese is going to be then 7. You just have to enter the number only. You don't have to worry about the sign. Okay. So in potassium permanganate, oxidation number for manganese is 7. The next one over here. So we have potassium permanganate in our equation. So potassium permanganate is over here. It is becoming manganese sulfate. Now we're going to find out what is the oxidation number for manganese sulfate. So we can treat manganese sulfate also the same way we treated potassium permanganate. Oops. We can treat it as a charged species, which is, we can break them into ions. What did I do? Where's my pencil? Okay, it's right there. Good, found it. Okay, manganese sulfate. We were here, right? Yeah. So what we have here is manganese sulfate. Potassium permanganate becoming manganese sulfate. So we want to find out the oxidation number for manganese. We can break them into ions. MnSO4. Sulfate is a polyatomic ion. What is the charge of sulfate? -2. If sulfate is -2, what's the charge of manganese going to be? It's a neutral compound, so sulfate is -2. So then the manganese has to be +2. Right? So we right away we found out what is the oxidation number for the manganese. That's going to be 2. So manganese going from potassium permanganate to manganese sulfate. And we found the oxidation number for potassium permanganate is 7. Manganese sulfate 2. Plus 7 goes to +2. So the number goes down. If the oxidation number goes down, what do you call that? That is a reduction. So the next question is, based on your answer to question 4 and 5, were manganese atoms oxidized or reduced in this reaction? Remember, it is going from +7 to +2. If the number goes down, which is reduced. So the manganese atoms were reduced. Okay. So if the number increase, it's oxidation. If the number goes down, that is a reduction. Okay. The next one, what substance served as an oxidizing agent in this reaction? Oxidizing agent. So sodium oxalate going to carbon dioxide, right? And that was oxidation because it's going from +3 to +4. This is oxidation. and then potassium permanganate. Potassium permanganate going to MnSO4. Number go from +7 to +2. This is reduction. This one going from +3 to +4. Oxidation. It's asking what is oxidizing agent. Oxidizing agent is the one that undergoes reduction. Reducing agent is the one that undergoes oxidation. So when it is asking oxidizing agent, then you want to find out who is undergoing reduction. Reduction is undergoes by potassium permanganate. So because of that, oxidizing agent is going to be KMnO4 because that's what undergoing reduction. Okay, and it's the one that you choose from the left side. It's not manganese sulfate, it is potassium permanganate. The number goes down, which is reduction. The species that undergo reduction is the oxidizing agent. Okay, and then the next one asking what substance serves as the reducing agent. Now the reducing agent is the one that undergoes oxidation. Who is undergoing oxidation? We talk about it. Oxidation undergoes sodium oxalate. +3 become +4 carbon dioxide. So the oxidation, the species that undergoes oxidation is the reducing agent. So your reducing agent is going to be sodium oxalate. Okay, because this is helping the other person to undergo reduction. So this is the reducing agent, the person who is helping for it to undergo reduction. This one is the reducing agent that undergoes oxidation. Okay. Next one, a solution of 1 molar lead nitrate placed in the inner cup, and you will see this in the virtual video also for this lab, how to construct a cell with 2 cups. So you have 2 cups, one is a porcelain cup. Solution of 1 molar lead nitrate placed in the inner cup. So you put 1 molar lead nitrate in the inner cup, and then the lead strip is immersed in the solution. If the solution is lead, your electrode also going to be lead electrode inside. And then you take another one, outer cup, you put zinc solution, zinc nitrate, and then this is going to have a zinc electrode, and then you construct an electrochemical cell. The inner cup, which contains a porous barrier that allows ions to flow through, placed in the outer cup, and the metal strips are connected with the wires that pass through a voltmeter. So the metal 2 electrodes connect with the voltmeter. Okay, we have 1 molar lead nitrate with a lead strip, and then we have zinc nitrate with zinc strip. Zinc and lead, these two are our electrodes, and we are also given the standard electrode potentials. Zinc is given as, the 2 is always written as a reduction, as a convention. So zinc plus 2 electron giving zinc becoming reduced electrode potential -763, and then the lead is -0.126. It's asking us to calculate the cell potential for the cell. Use the standard reduction potentials provided to calculate the standard cell potential expected for this cell. How do you calculate the standard cell potential? So basically E naught cell equals E naught cathode minus E naught anode. So we are given the cell potentials. One of these are going to be a cathode, the other one going to be the anode. Cathode is where the reduction takes place. Anode is where the oxidation take place. Okay, normally oxidation will take place whichever has the more negative electrode potential. More positive E naught value will serve as the cathode, that is where the reduction take place. Okay, more positive E naught value electrode is where the reduction take place, which is the cathode, and more negative E naught value is going to be your anode, and that is where the oxidation take place. So the more negative one here is negative 0.763. So that is where the oxidation take place, which is the anode. Okay, so when you select, your anode is going to be more negative one and your cathode is going to be less negative or more positive one. And when you set it up like that, your E naught cell will give you a positive value. When the E naught cell is positive, then you can have a spontaneous reaction taking place. Okay, so let's see now. E naught cell, E naught cathode. Remember, we figured out our cathode is negative 0.126 minus, and then the anode negative 0.763. So this is negative 0.126. This will become positive 0.763. So when you get the difference of these two, there would be going to be your E naught cell, which is going to be 0.637 positive, so which is a spontaneous reaction. Okay, okay, now when you, the next question, let's see. Same thing is written here. Which substance will appear on the reactant side of the balanced net ionic equation for the spontaneous electrochemical reaction that takes place in this voltaic cell? Now, if we construct the two reactions to give us the overall reaction, remember this is going to be your oxidation, which is your anode. This is going to be your cathode. Okay, if this is your anode, this is where the oxidation take place, and so we have to write our equation oxidation like this: zinc becoming zinc 2 plus by losing 2 electrons, and then the standard electrode potential for that reaction is -763. And in the cathode where the reduction take place, that's going to be Pb2 plus taking 2 electrons becoming Pb. The electrode potential is this one. So when you add the two together, your overall reaction going to be zinc plus Pb2 plus 2 electrons cancel, will become zinc 2 plus lead. That's the overall reaction. Now, which substance will appear on the reactant left side of the balanced net ionic equation for the spontaneous electrochemical reaction that take place in this voltaic cell? So when you add these two together, we will have our overall reaction. So the left side we will have zinc and lead 2 plus. What we're going to have on this side going to be zinc and lead 2 plus. Okay, those are our reactants. And then the next question. Okay, the same question you guys can read. Which metal strip serves as the cathode in this voltaic cell? Cathode, which metal strip? So we have to identify what is our cathode. Remember we said the highest electrode potential is where the oxidation or the anode, and this is going to be your cathode. So then which is one is going to be your cathode? That's going to be lead. Okay, not lead 2 plus. Lead 2 plus is a solution. It is a lead solid is going to be your cathode. And then what about the anode? Of course, the anode is where the oxidation takes place. So that's going to be zinc strip. Okay. And then the next one, same question. Which metal strip serves as the negative terminal in the voltaic cell? Normally, the negative terminal is where the oxidation takes place, because that is where the electrons are being generated. Right? Oxidation means the metal is losing electrons and you are generating electrons, so that's going to be more that is a negative electrode. So whichever the strip that is undergoing oxidation is the negative terminal, which is going to be your, which one, where is the oxidation take place? It's going to be your zinc. Okay, it's going to be zinc. Negative terminal. Positive terminal is your cathode, which is lead. Excuse me. So the next question is asking your positive terminal, which is going to be lead. Okay. Oh, that's it. Okay, great. Okay, then I'll talk to you later. Bye-bye.